All right, now we're going to work example 2. Example 2 asks us to multiply the polynomials x minus 1 times x to the fourth plus x cubed plus x squared plus x plus 1 using a table. Then asks us to generalize a rule for any situation like this. So this is pretty simple. We've got a binomial multiplied by a 5-term polynomial. So we can do a 2 by 5 table because we aren't actually skipping any of our exponents. This is x to the first power. We have x to the 0 power there. Then we have x to the fourth, third, squared, to the first power, and then again x to the 0 power. So we're actually in descending order for all of these. We don't need to skip anything in our table or add anything to our table. So I'm going to draw a 2 by 5 rectangle. You can draw the rectangle standing up or laying down, it doesn't really matter. Okay, we've got x minus 1 on the side, and we've got x to the fourth plus x cubed plus x squared plus x plus 1 on the top. So the problem asks us to generalize a rule for any situation like this after we do our multiplication. So first off, we've got to do our multiplication. X to the fourth times x is x to the fifth. X times x cubed is x to the fourth. X times x squared is x cubed. X times x is x squared. And x times 1 is x. X to the fourth times negative 1 is negative x to the fourth. Negative 1 times x cubed is negative x cubed. Negative 1 times x squared is negative x squared. Negative 1 times x is negative x. And negative 1 times 1 is negative 1. Again, our like terms are going to be diagonal because we didn't skip over anything. We can combine like terms, and you're going to notice something happens here. You're going to have x to the fifth. X to the fourth minus x to the fourth is 0. X cubed minus x cubed is 0. X squared minus x squared is 0. And x minus x is 0, leaving you with just minus 1 at the end. So this seems unique. It's a unique situation. And based on what's in the problem, we can come up with a rule that generalizes any situation like this. So it doesn't really matter where you start, whether it be x to the fifth, x to the 100th, x to the fourth, x squared, anything like that. As long as you are sequentially going down on your exponents, so from 4 to 3, for instance, to 2 to 1, and then ending up with a plus 1 at the end. You've got to go all the way down. So that needs to be true. You've got to have this x minus 1 here, and you've got to have coefficients of 1 for this to work. But no matter what type of problem you have, if all of this is true, you can build a rule that reads this. So x minus 1 multiplied by x to the n plus x to the n minus 1, because if this is 6, then this would be 5, correct, for our exponents, plus x to the n minus 2, and we could continue doing that until we get all the way to x squared plus x to the first power plus 1. So we can take that all the way down to 1. This will always equal x to the n plus 1 minus 1. So for instance, if I had the problem where this was x to the 9th plus x to the 8th plus x to the 7th all the way down until I get to 1, then my answer would simply be x to the 10th minus 1. We don't need to really do any math for it because we have this rule now that actually tells us how to do it. All right, let's move on to practice 3. Practice 3 is very similar. We can build a 2 by 4 box. Building a 2 by 4 box. Okay, we see we have our 2 by 4. We've got x minus y on the side, and we've got x cubed plus x squared y plus xy squared plus y cubed on the top. So we've got x to the 4th, x cubed y, because x times x squared is x cubed. X times x is x squared. There's no y here, so just y squared. And then x times y cubed is xy cubed. Here's a little bit trickier part. This minus sign here is actually a negative in front of that y. So this entire line here is going to be a negative times a positive because all of these guys are positive. So I can go ahead and just put a negative in front of all of them. The rest of it is going to be simply doing multiplication. So don't even look at the negative anymore. I can say y times x cubed is x cubed y. I can kind of tell that I did this part correctly because I've got an x cubed y here, and exactly where I would want to expect an x cubed y, I've also got an x cubed y. We've got y times x squared y. That's going to give me x squared y squared. We've got y times xy squared, which will give me xy cubed. And we've got y cubed times y, which is y to the 4th. Again, we can combine like terms diagonally. And something very similar to the last problem happens. We have x to the 4th minus y to the 4th. So we get this same type of rule here. We know that if we have a situation like this where the exponents on the x's are going down while the exponents on the y's are going up, then we can, and we've got this x minus y at the front, then we can say that if we have x minus y multiplied by x to the n plus x to the n minus 1 times y plus x to the n minus 2 times y to the first power, or second power rather, plus dot dot dot, and on and on and on until x becomes 1 and y is all the way up to y to the n, plus x to the first y to the n minus 1 plus y to the n, then we can say this will always equal x to the n plus 1 plus y to the n plus 1. So again, if we had a situation that had x to the 7th, this would make that 6, this would make this 5, and of course this would be 7 and 6 over here, and we did that, then our answer would be x to the 7 plus 1, which would be 8, plus y to the 7 plus 1, which would be 8. So very simple to figure out what the answer is going to be if you build a rule for it. All right, and practice 4. Let's talk about this real quick. So we've got x squared minus y squared times x squared plus y squared. We want to come up with a rule that for any expression, like x to the n minus y to the n, x to the n plus y to the n. Here again, we can build a 2 by 2 box, or we could just FOIL this out. It doesn't matter either way. So we've got x squared minus y squared, and x squared plus y squared. X squared times x squared is x to the fourth. X squared times negative y squared, remember that negative comes out front, and we've got x squared y squared. Then we've got x squared times y squared, which is x squared y squared. And y squared times negative y squared, which would give you negative y to the fourth. Combining like terms diagonally again, we get x to the fourth minus y to the fourth. So here we've got a similar situation. If we have x to the n minus y to the n multiplied by x to the n plus y to the n, then we can say that we're going to end up with x to the 2n minus y to the 2n. And there's our rule. So whatever we have originally, we're just going to multiply it by 2 in the exponent and put a minus sign in between. So if we ended up with something like x to the third minus y to the third times x to the third plus y to the third, our answer would then be equal to x to the sixth minus y to the sixth. And that would be all we'd need to do. All right.